Hello everyone, welcome to my class. In this class, I'll discuss with you all how to determine the antilog of a number. In one of my video, I have already discussed how to determine the log of a number, that means the logarithm of a number. In this class, I will try to discuss with you all how to determine the antilog of the number. Okay, so let's check this, how we do or find out the antilog of a number. You can see here, this topic determination of antilog of a number is from standard 9, okay, from advanced maths subject, okay, from the chapter named logarithm. All right, so from this chapter we'll try to discuss this topic. So I have taken here three examples. All right, three examples I have taken keeping in mind three different types of numbers. Okay, three different types of numbers, how to determine the antilog of this type of number, this and this. Okay, so most of the problems set in the textbook are based on among any of these, okay, types. So let us see one by one how to determine the antilog of this and this. All right, so before I start showing this one, let me show you this how to write the get the antilog mathematical relation. Okay, so look at this one. Log of x, all right, log of x equal to t, suppose. So when we know the value of x, then we can easily find out the value of t. All right, suppose log of, in place of x is suppose 0.2013, suppose. So when we know log of x, that is x, value of x, when we know 0.2013, we can find out the value of t. We, after using the log table, you can get the value 1.30384. Okay, in one of my video I have already discussed how to use the log table to find out the log value of a number. Okay, that you can check that video, you can easily understand. So I am trying to tell you here, if you know the value of x, that is x is 0.2013, we can find out the value of t. Now in this relation, what if we know the value of t? How can we find out the value of x? Alright, instead of knowing the value of x, if we know the value of t, how to find out the value of x? Okay, this value of x we can find out by using antilog. How? See, if we have log of x equal to t, in the next line we can write here x equal to antilog of t. Alright, this line log of x equal to t, okay, if we need to find out the value of x and we know the value of t, then what can we do? We can write the next line as x equal to antilog of, this log will become antilog of t. So we have to find out the value of x, we know the value of t. So if we use the antilog table, for this value, okay, then we can easily find out the value of x. So this is the concept of antilog. If log of x is something and we need to find out the value of x, we know the right hand side value, we can use antilog, okay, table to find out the value of x, okay, when the value of t is known. Alright, this is the concept. So in many of the problems you will come across to this kind of step where you need to use the antilog relation. Alright, and you have to find out the value of x, y, or any kind of variable given. Okay, so we may discuss this one in other video. Here we will try to find out, see how to determine the antilog of a number. Okay, in a simple way. Let's. Here you can see, find the antilog of 3.7523. Let me write this. Therefore, what can I write is antilog of 3.753. Alright, we are asked to find out the antilog of this, so we can write antilog of this. equal to. You have to use antilog table for that. Okay, while you solve this. So while using antilog table, this integral part you have to ignore. Okay, you only need to consider this decimal part, that is 7523. Okay, why we have to ignore this integral part is because this integral part is found out because just by considering the number of digits in the integral part of log number. How? Let's see. Suppose log of 43.61 is equal to 1.63959. The log value of this number 43.61 is 1.63959. Here you see, we can do what? Therefore 43.61 equal to antilog of 1.63959. Alright, this we can write. By this concept, if log of x is this, log of x is equal to t, then x equal to this. So if log of 43.61 is this, so 43.61 is antilog of this. What does it mean? This antilog of 1.63959, here this integral part, how we get this integral part? This integral part is from here. And how we get this integral part? This integral part we get based on the number of digits in the left hand side of the decimal point. We know if the number of digits are 2, then the characteristics will be 1 less. So if 2, 1 less is 1. If in some other cases, if there are 3 digits, suppose instead of 2, then characteristics we get is 2. Alright. Similarly, here 2 digits, so 1. So antilog of 1.63959, this integral part is based on the number of digits before the decimal point. So we can ignore this one. Okay, we can ignore this one. When we use the antilog table, we will only use this part. In a similar way, when we do this one, antilog of 3.7523, so we will only consider this part, we will not consider this part. Okay, when we use the antilog table. So what we write is, we will first try to use the antilog table. Okay, let's see how to use antilog table. From antilog table, the way we have used, using this for time being, okay. The way we have used log table, in a similar way we can use antilog table also. Okay. Antilog table also, there used to be columns and rows. Okay. Suppose this is column A, where 2-digit numbers used to be there. Starts with 00, 01, 0, 02, like this. Okay. Goes on. Okay. You will get till 99. You will have. Okay. Till 99. So there is to be column then for the value for this row. Suppose it starts with 1, 0, 1, 2, 3, goes like this, okay, till 9. I have shown already in one of my video. Here also it starts, this is main difference part. So it starts with 1, 2, 3, okay, goes like this till 9. So the way you can see log table, antilog is also same. So similar way, if I consider these 4-digit numbers, significant digits, what are the first 2 digits? 75. 75 will come. Okay, at time 75 will come. Then third digit is 2, so I take 2 here. Then from mean difference, how much? 3. Mean difference, 3. So straight to 75, column 2 and mean difference 3. What are the values? Okay, we check. Straight to row 75 and column 2, we have value 5, 6, 4, 9. If you check the antilog table, 4 digits. Okay, 5, 6, 4, 9. Straight to mean difference 3, the value is 4. So the way we add in log table, the same way we do here also. What do we do? 5, 6, 4, 9. Okay, plus 4. You have 5, 6, 5, 3. Okay, so this is the value you get by using antilog table. Alright, so you will write here 5, 6, 5, 3. Okay, now since it is added already, let us do this one. Alright, so 5, 6, 5, 3. This is the value you got. Now, after writing this value, this integral part you have to consider, which we have ignored in the starting point of using antilog table. This integral part we have to consider now. If it is 3, this integral part we use for putting the decimal point. Here we have to put the decimal point. Okay. If it is 3, the decimal point will be placed after 4 digits. That means 1 more. So from the left side, 1, 2, 3, 4. Here you have to put the decimal. First you will ignore initially when you use an antilog table. You will get the value. Then after that you have to use this integral part. Okay, the value you have to use, and by using this you have to put the decimal point. And how you will use? If it is 3, you will put the decimal after 1 more digit. It is 4 more digits. So 4, 1, 2, 3, 4. If it is 4, you will put the decimal after 5 digits. So there is no 5 digits, we have to make one by adding. So since we can put after 4 digit 0, so you can write 5653 points. Okay, so this is the result of antilog. Okay, of 3.7523. Let us see the second example. Okay, this one. So in the second example, here it is minus 3.6423, which is not same with this one. This is positive, this is negative number. How to do this one? How to find out the antilog of this value? Whether it is same or not, let's see. This one, since a negative number, it means if I make it 2 parts, it will be minus 3 minus 0.6423. That means the decimal part and the integral part both are negative. When we have the decimal part negative, okay, we cannot find out antilog. To find out antilog, we need to have the decimal part as positive. Alright, so since here both the integral and the decimal part are positive, by looking at the number we can say. But for this, both the decimal and the integral part are negative. So if the decimal part is negative, we cannot find out antilog. We have to make it positive. Okay, let's see how we can make it positive. Very simple. Minus 3 we can write as minus 4 plus 1. Okay, and this minus 0.6423 will remain as it is. Alright, then what we can do? Minus 4, subtract this 0.6423 from 1. How much you will get? You will get plus 0.357. Now this decimal part has become, you can check the subtraction, alright. Now this decimal part has become positive. Now you get this antilog, okay. But you have to write in standard manner. So minus 4 plus 0.3577, we can write 4 bar 0.3577. Alright, I have already shown in one of my video where I have discussed the determination of logarithm. Okay, you can check that video. How we can write this line to this. Okay, so this kind of line we can write as 4 bar 0.3577. Now this is positive. We can find out the antilog of this. Therefore, what will be antilog of minus 3.6423? We can write antilog of 4 bar point 3577. Alright, this value means this, so antilog of this will be antilog of this. Okay, very simple. Now we will be finding out the antilog of this value. Alright, so the way we have used here the antilog table, where we have initially first ignored the integral part and then we have considered only the decimal part. Okay, here also we will do this. Here also we consider the decimal part. Initially we will ignore the integral part. So what is that? 3577. Okay, let's see 3577. So this one I am erasing now. So like that, suppose we need 35 coulomb 7, main difference also 7. Alright, main difference also 7. So what is the value straight to 35? You will get the value straight to 35 is 2275, and straight to mean difference 7 you will get how much? 4. So what you have to do is you have to add this, you know. So very easy. 2275 plus 4 how much? Okay, 2279. So 2279. 2279. Okay, I have already shown how to add this one. Okay, the previous case 2279. So 2279 is the answer. Now, before we declare the answer, as we have considered the integral part at the end for placing the decimal point, here also we will be considering this integral part. Okay, but not for placing the decimal. Okay, for putting the number of zeros, because it is 4 bar. Okay, it's a negative number. So what we do, if it is 4 bar, okay, the number of zeros you have to put between the decimal point and the first non-zero digit. Okay, so how many zeros you can put? Okay, if it is 4 bar, you will put the number of zeros 1 less than this. So how many zeros you have to put? 3 zeros here. 1, 2, 3. Alright, so this one point here. Follow. So it is becoming 0.000227. I repeat, in this question, since integral part is only 3, so we use this integral part to put the decimal point. If it is 3, we put 1 more. We count 1 more digit and then we put the decimal. So after 4 digits. Here this integral part is 4 bar because it was negative. Okay, so we use this integral part, okay, to put the number of zeros between the decimal point and the first non-zero digit. And how many zeros we will put? If it is 4, we have to put 1, the number of zeros 1 less than this value. Okay, so just check the difference. Alright, after we put, that will be our final result. Okay, so this is the difference between this finding out antilog of this kind of number and this kind of number. Alright, so let us see. One more is very simple. It is important. I mean, very simple in the case. It is of this type only. But since here is 0, so I just want to show you how we get the value of antilog. Okay, when the integral part is 0. Let's see. Okay. Therefore, antilog of 0.013. Here we need not do any simplification because it is a positive number. When we have negative number, then we need simplification. Then, okay. When we have a positive number, no need. So obviously, like this, we'll consider these digits. We will ignore the integral part. Okay. So if you check straight to 0, 1, alright, straight to 0, 1, and column number 3, straight to 0, 1 and column number 3, How much is the value? It is 1030. 01, 01, 3, 3. Okay, mean difference how much? 1. Alright, mean difference 1. So, what is the value below mean difference 1? If you see the interlog table, you will get it is 0. So, we have 1030 plus 0. Same, isn't it? 1030. So, what is the value? 1030. Alright, now, like this, we use the integral part to put the decimal point, isn't it? Here also we will use this integral part to put the decimal point. When it is 3, we put the decimal point after counting the number of digits 1 more than this value. So this was 3, so 1, 2, 3, 4. Here it is 0 only. But yes, it does hold. If it is 0, we have to put the decimal, okay, after how many number of digits? 1 more than this 0. So what is 1 more than 0? It is 1. That means decimal will put after 1 digit from here. Follow? So answer is 1.03. That's it. Okay. So if you see the integral part, why I have shown this is, if you see the integral part is 0, do not get confused. If it is 0, what is 1 more than 0? It is 1. So you put the decimal after 1 digit. Okay. The rest is all same. Okay. Like this only. So this is how we can determine the antilog of a number. These are the types I have shown you. Okay. If you still find any doubt, okay, you can check repeatedly. Okay. I hope I could make the whole point clear to you. Okay. So that's all from this class. Okay. Thank you.